Lesson 22, 3-2 notes functions. A function is a relation in which there is only one value of a dependent variable for each of the independent variables. We're going to be able to determine by looking at graphs, equations, ordered pairs, and determine if they are functions or not. A vertical line test is a method to determine if a graph is a function. In order to do the vertical line test, you make a vertical line, and if that vertical line intersects the graph at more than one point, it is not a function. We're looking for your line, your vertical line test, to only cross your graph function or line in one spot. You will also come across the lesson function notation. Function notation is basically a way to describe an equation. For instance, you have y equals 3x minus 2. That is in slope-intercept form. This can be written as f of x equals 3x minus 2. F of x is in place of y. Basically, f of x is stating that f is a function of x, so this graph here would be considered a function. Or in this case, this would be an equation, which would be a function. If you were to graph the equation, it would also be a function. The diagram here, or table here, just shows there are different ways to represent a function. One being a table, two being an equation. Remember, f of x here is basically the same as y. This is saying a function of x. Or you can graph things and determine if it's a function. Anytime you have things that are graphed, such as a, we're to determine if it is a function. I use the vertical line test. Remember, when you do the vertical line test, a vertical line will only intersect your graph in one spot. As you notice, when I make my vertical line here, it crosses in two spots on that graph. Therefore, this graph is not a function. As stated, not a function, vertical line test, intersects our graph in two spots. In B, if we were to construct a vertical line, you notice that our vertical line intersects in one spot. And you can draw a vertical line anywhere, and you will see that your line only intersects in one spot. I drew three different lines here, and they intersect your graph in one spot. B is a function because it intersects your graph in one spot. So it is a function. C, they give us a list of ordered pairs. You should be able to look at your ordered pairs to determine if it's a function. Your three ordered pairs, 1, -4, 2, -4, 6, -4. I'm just going to prove to you that if I were to graph this, this would be a function. I can already look at the ordered pairs and say they're a function. Reason why is when you graph, so I'm just going to go ahead and plot these 3 points here on my graph. There's 1, -4, 2, -4, and 6, -4. Again, on a graph, if I were to draw using the vertical line test, it would cross in one spot there. It would cross in one spot here. So any spot I would draw a vertical line, your vertical line test would still only intersect one of the points. Therefore, C is a function. Same concept in D. Again, they use domain and range. Remember, domain is your x values. Your range is your y values. Again, I'm just going to go ahead and plot these and prove to you that here in D, this would actually not be a function, and then I'll describe C and D. In my graph here, I'm going to plot negative 2, 2. It's my first ordered pair. Negative 2, 2. My next ordered pair is 0, negative 1. My third is 5, 9. 5, 9. And I have 5, 6. Remember, if I were to use my vertical line test, it'll only intersect your graph in one spot. Well, yeah, if I use my vertical line test here, it does intersect only one point. However, if my vertical line test is used up here, it intersects in 2 points. When it intersects in 2 points, your graph is not, or your table or ordered pairs are not functions. So this is not a function. Another thing that you can easily look at is just the numbers here. Well, this is a function. Your x values, 1, 2, and 6, are all different. Your y values happen to be the same. Negative 4, negative 4, negative 4. When your x values are the same, or different, when all your x values are different, you will have a function. If you look over here, all of your x values are not the same. You have 5 and 5. Well, when you graph that, one was 5, 9, the other was 5, 6. When you have the same x values, it is not a function. So you won't even have to graph on your assignment. You should be able to look at your ordered pairs and determine whether it's a function or not. In example 2, you're going to be evaluating functions. You have f of x equals 3x minus 4. You're going to find f of 2. Basically what's happening here, instead of x, you will use 2. So where x is present, we will now substitute in 2. So your new equation would be f of 2 would be equal to 3 times 2 minus 4. So instead of 3x, we have 3 times 2. You would keep working down, solving. 3 times 2 is 6 minus 4, winding up with equaling 2. So your answer in A is 2. B, you have g of x equals x squared plus 2x. Instead of using g of x, we're using g of 5. So substituting 5 in for x, we have 5 squared plus 2 times 5. 5 squared is 25 plus 10. And in B, we would wind up with 35 as an answer. C, instead of t, we have h of t. We're going to use h of negative 8.9. We will substitute in for t, giving us h, well, equaling negative 8.9 plus 2.1. This is absolute value. Solve what's inside your absolute value. Wind up with the absolute value of negative 6.8. Absolute value is the number's distance from 0, so it would be 6.8. Example 3, where we're going to evaluate a few more functions. As you notice in A, it's a little bit different. We have g of x. Now we're going to have g of 3 minus 1. 3 is still going in place of x. So when we put 3 in place of x, it would look something similar to this. X to the third, we now have 3 to the third. Minus, in for x is 3. Then we tag this here on at the end, our minus 1. When we work through it, 3 to the third power is 27. We have minus 3 minus 1. Do your computation, and you'd wind up with 23. Down in B, a hair different than the others as well. In this case, we no longer have a number, we have another variable. So instead of s of t, we're using s of a. So substitute a in for t. We have 7 times a plus 6. So we just put a in place of t. We solve. 7 times a is 7a plus 6. So our answer is 7a plus 6. Down in example 3, notice we are substituting 2c minus 3 in for n. When you substitute in for n, it is no longer 4n. You have 4 parentheses 2c minus 3. Here we would use the distributive property. We would distribute our 4. So we have 4 times 2c would give us 8c, and 4 times negative 3 is negative 12. This concludes our lesson on 3-2 functions.